The following content has been provided by RWTH Aachen University.
All right. Hello and welcome everyone to the fourth lecture for iOS app development. So now I am setting up everything here on my screen. If there are any questions, any issues, just either raise your hand or just start talking so I can recognize it. In the breaks, I will take a look at the chat, whether there are some questions that I can answer. But if there's something immediately bugging you, just raise your hand or let me know by talking. Okay, so today we'll be talking about navigation and workflow on the one hand, and a little bit more about Swift paradigm, Swift language on the other hand. But first, let's start with a little recap of last week's lecture. And there first, Jan talked about strings and how you can create them and what are there some ways to navigate them. So that you create, if you want to have a character, you need to explicitly mention that. Because usually if you just have quotation marks and something then between them, the compiler will automatically just assume that it is a string and will assign the type string to that variable or constant. So if you need character particular, be specific about that and tell the compiler that you want just a character. Then we'll also talk about functions. So in general, how to set up functions, what is the structure that you need to employ, how you specify return types, and then a little bit more about parameters. How do you find parameters and what is so particular in Swift about them? That is that you need to provide a specific name for that parameter, and that if you call a function from the outside, you also need to specify that you what parameter you're referring to. And there are two different types that you set up there. And if you have just one argument for a specific parameter, one name, that is then the same for both inside the function and outside of the function. But you can also specify two names for a parameter. And then one of them is the so-called argument label is used outside of your function, so that if you call the function, you specify this name, which makes it then possible to call functions in a very easily readable manner. So if you have a say hello to person A and to person B, that is then easier to read on the outside, while inside you use then the internal name of that parameter. And then a large part was about structs, where we talked about what is so specific about structs in Swift and why they're used there so often. And the reason for that is that you have a lot of functionality that structs already offer you. So you can have structs with functions and that you can change elements in that struct. And so if you don't really need inheritance, you don't really need to switch over to a class if you want to use that. And also about initializers, how you what initializer do you get automatically if you don't specify anything. You directly get the member-wise initializer, where you specify every property of that struct you want to create, and that if you want to change any of these properties, that functions can't do that directly. You need to specify it with a mutating keyword, specifying that this function will change something in the struct. And then we also talked a little bit about computed properties and property observers. So computed properties, that it's not something you assign directly, but on the other hand, if you call that property, it will compute what it is returning to you based on the other state of the struct. So we had the example of the temperature, that it only has the property that you can set directly, which was Celsius. And then if you query for Fahrenheit, it will calculate the Fahrenheit value dependent on the current Celsius value of the struct. And then for property observers, that's quite a handy way to react to changes when you adapt the property. So there you can specify something that should happen before you change the property, or the property is changed. There you have the will set observer that you specify code for, but then you also get the did set observer, where you can then maybe update other states of the struct based on what was currently changed. And after that, we went a little bit more detail also into classes. And classes, yeah, they are not really that much different from classes you know in other languages, but they're also not that different to the structs we talked about then before. But you can use classes if you want to have inheritance. Otherwise, structs don't have inheritance. So if you need that, then you need to use a class. And a very important difference that you need to remember is that structs are value types while classes are reference types. So if you pass around a struct, you will create copies of that, and it won't directly change any properties. If you change it in one location, it won't change the copy automatically. While for reference types, so classes, if you pass that around, you're passing around the pointer, and you can change the object and will change then in all the different areas where you used it. And in the end, we then spoke also a little bit about collections and their arrays and dictionaries in particular, and a little bit about, yeah, how do you create them, how do you access certain values, and what about functions on dictionaries, for example. And there again, very important thing to remember is that collections or arrays and dictionaries are also value types. So if you pass them around, if you pass it over to a function and you change something there, it won't automatically adapt the original array or the original dictionary that you passed over. For that, you need to return it and then assign it all manually. Something, yeah, you might run into, but it's also something, if you once you remember it, it's quite handy and makes things a little bit more safe for you to do. Okay, so then today we'll talk first a little bit about optionals and other Swift constructs, and then in the end look a little bit more into Xcode and how to transition between different screens there, and what options do you have there directly. But yeah, first starting with optionals. We already saw optionals in the first lecture and then along the way, because they're quite something that is used often in Swift, and it's central to the safety of the language. So if we here consider this example, if we have here a struct of a book, and a book has a name and a publication year. So if we create then or want to create a record of a new book, we just call the member-wise initializer here, giving it the name of the first Harry Potter book and when it was published. We can add that 1997 there, and similar for other books where you already know when were they published and you have the name. But the problem then is, what if you want to already add a book that you know the name for, but it hasn't been published yet? So one way that was often used or is often used is, yeah, you have just some number there that doesn't really make sense or isn't used anywhere else, isn't logical, and use that to determine something. Yeah, it won't happen there. So here we have an unannounced book. Can already give it a name and then set the publication year to 0 because, yeah, it hasn't been published yet. But the problem is that the 0 really isn't something accurate, because yeah, it would mean that the book is over 2,000 years old, which, yeah, doesn't make sense. But yeah, we need to put in an integer because we don't have anything else that we can add to this publication year property of our struct. So what we really would like to do is to specify that the publication year is nil. It has no value. It doesn't have a publication year at this point. But for the type safety arguments in Swift, that isn't possible because we can't set an int to nil. An int always needs to have a number in it. And that is something, yeah, really central of this language. If there is a type associated with a variable or a constant, you can be sure that that is also in there. But the way how Swift allows you also to specify a nil value is by using the optionals. And optionals are essentially, they can have two states. And one state is it has a value of the expected type, or the other option is that there is nothing at all in that. So that is then the nil value. And optionals, they are, you can recognize them with the question mark that they have behind the type. So here for the string is of type string optional. And that is its own type. It either then is a string inside that optional, or there's nothing inside that optional. But yeah, string optional is the type that you're using here. And then for that, if that is the type that you have associated with the variable, you can assign nil to that variable, and the compiler won't complain about that. But you can also, with the same way, just put the string something into that variable as well, and that is all fine. So for our example with the book, what we could do is have the publication year of the type optional integer. So then if we have already a publication year for that book that we want to create, we simply put that in, and otherwise we can specify that there is nothing that we can input there at the moment, and just assign nil to that to the publication year. So, but if that is if we have an optional, we can't simply just use that, for example, for calculations here. If we want to, for whatever reason, add 5 years to the publication year, that won't work directly, because it could be that there is nothing in the publication year, and then we couldn't add something to it, and so the compiler would crash at that point, or the app would crash at that point. So the compiler won't even allow that. So if you want to use the optional, you want to access the type that is in it, you need to unwrap it first. And the most straightforward way that you can unwrap an optional is by using exclamation point behind the variable. That will tell the compiler, okay, I know that there is a year or an integer in there, use it as an integer. And that is called forced unwrapping. So here we can just specify a new constant unwrapped year and assign that to the publication year with the exclamation point, which will take out the integer value of the publication year and then assign it to the unwrapped year. But that's the problem. Here you specify, okay, I am sure I know that there is an integer in the publication year that you then can use. So if there's no integer then in the optional, that will then crash at runtime. And yeah, it negates the whole reason of using an optional in the beginning, because yeah, if you just force unwrap it, then you could have just used a integer directly. So this is something, only use that if you're really sure that there is a integer in that publication year, for example. So what you usually do then is to first check whether that is the case. So that before you force unwrap your optional, you check that the variable isn't set to nil. So that in this example, you would first ask if the publication year is not equal to nil. And if that is the case, then you can be sure that there is an integer in that optional, and you can use the exclamation point, the force unwrapping, to take it out. And then you assign actual year with the publication year that you took out. But of course, that is quite something that is will be tedious if you use it very often and you need to work with optionals all the time. So there's a shorter version where you combine all these lines essentially into one if statement, where you use the if-let structure that you will see quite often in Swift and all the frameworks for iOS. So what this line or what this code does, both checking whether there is an optional or a value assigned to that optional, and directly also assigning it. So with the let actual year equals the publication year, you're essentially trying to assign the optional to that new constant. And if that's possible, that will assign and will go in the first bracket where I can print out the actual year. Here, then actual year will be of the type int, so of the type that is enclosed in the optional. Or you can react to the other case here in the else brackets. That will be then the case where the publication year is set to nil. And this really is a structure you will see quite often, and it's used in a lot of different frameworks. And it's also something you will use very often if you use optionals, because this is a safe way where you can quickly check whether the optional is filled with a value of a specific type, and then directly assign it and continue on using that variable or constant from there, where you are then also sure that it has the actual type in it, or react accordingly if it's not in there. But yeah, of course, if you have multiple optionals, you could change that together like this, where you have then if let statement for the actual year, or for the book edition, if that's another optional that we added there too. And you do that step by step, one after the other. But of course, yeah, that will also be quite a hassle if you have there a lot of optionals to unpack at once. So you can also do that in one if statement. So here you have the if let actual year equals publication year for the first optional that you try to unwrap and assign to the actual year constant. And then separated with a comma, you just add the next optional and try to assign that. And this will fail if one of the optionals there doesn't have a value inside it. You will only get into the block inside of the bracket if you were able, or it was possible, to assign all these optionals to their new constant or variables. So, and then again, inside of those brackets, you can be sure, yes, that constants will have the type of probably integer in this case. And optionals, yeah, they're their own type. You can use them everywhere where you use other types. So also in functions, where you can take here the URL is of URL optional. So you might pass over a URL in that function. Inside of the function, you need to check whether it's in there or react if it's nil. But you can also have the return type as an option. So here it is a string optional. You either return nil or you return a specific string. And then the context where you're calling this function needs to be sure or needs to handle that it's an optional, whether it's something in there or not. And also for initializing objects, for example, in classes, you can also have failable initializers that determine based on the parameters or the state of your application or whatever you may want to make sure that it needs to be handled first before you can create the object. You can have the init with a question mark behind it. And that means this initializer could also fail, that you can try to create an object and it just won't work. And in that case, again, the context where you're creating or calling, trying to create the object needs to be aware, yeah, that could also not work. And I need to check whether the construction of the option would actually work. Let me quickly look at the question here. I'm not sure how to cope with that means. You always need to be very specific when you're using an optional. So here the if let that will, assuming that it is referring to that, that will check whether the assignment is possible. So let actual year equals publication year. And in the if let construct, it will try to unwrap the optional directly and assign it to this new constant. So in this case, that essentially you could think of a Boolean idea which would work or not work. But if you use it outside of an if let construct, if you would just write let actual year equals publication year, that would make actual year also an int optional. So that will take the type into account as well. So it would carry over to the actual year. It wouldn't directly unpack it. But with the if let construct, that will try to unwrap it and only continue if that was possible. So why, I'm also looking at the question there, why is that helpful? Think of the example I used in the beginning, that there is something where I'm not sure that I can set it to a specific value here, for example, the publication year, because I'm not sure a book actually will have a publication year or whether it's used directly. And if it were possible to just assign nil to any type, if you have an int and I can just put nil in there, that is then very problematic because you can't really always be sure that it is an integer. So that's very often then that the system or your program will crash if you try to handle an integer and there is nothing in that. And to prevent that you are having to check every time whether there is actually an int or whether it's set to nil, or you always have to fear that it might be set to nil and crash everything. In Swift, the type safety is so strong that you can be sure if there's a specific type, if you have a variable of type integer, there will be an integer in there. It won't crash if you try to add something to it. If you try to add it with another integer, that will always work. But to again then allow the possibility, yeah, it might not be an integer. There might be nothing I can report there. That is where optionals are then used. And in that case, if there's an optional used, then you are back to the position where you need to make sure that it is an integer if you want to work with that, or first check whether it's nil and then react accordingly. Yeah, so if let is something that is, I'm not sure how it's done internally, whether it's a certain construct that they code differently, but for the if let, that is the structure you use to quickly unwrap an optional. We'll also look at a different method also in this lecture. So, but something that is also then possible with optionals to make it easier to work with them, something called optional chaining. So if we look at here, this example, we have a class of person. Person will have always will have an age, but they could also have a residence, so where they're living. But also they might not have a residence that is associated with that person. So the residence here is of type residence optional. And this will also help for all of the types that you create yourself. If you have, for example, here the person, if you want to use it as an optional, if you want to make sure that at some point you use it, could also set it to nil, or it could be a person. That is always associated directly. So you don't need to create a specific type of optional person. If you've created the type person, then there's also the possibility to use it as an optional. So yeah, Tarek, you have a question.
If I declare type the variable residence as an optional, and residence had multiple variables, are all of them optional too, or do we have to specify those individually like you did here?
Here, well, residence is here the own type, and the type is then defined afterwards.
If the address didn't have a question mark at the end, would the address attribute also be an optional?
You mean whether the address of the residence is an optional? That is an optional here as well, because we have address with the question mark. That defines that it is or declares that it is an optional. Okay. If I would have address without a question mark, then residence would always also have an address. And you can mix and match that. So for example, for the address, when you look at that, the address always will have a building number. It will always have a street name. It might also have an apartment number. Okay. It will be. It might have a string in the apartment number. To be clear, it will always also have the apartment number property, but that might be nil, or it might be a string in there. That is always the case. So the person will have a property residence, but the property or the residence might be also nil, or it will be a residence. Then it will also have or might have an address. It will always have the address property in the residence.
All right, thank you.
Okay. Maybe it will also become a little bit more clearer with the example how we then, if we want to use that. So if we have then here a person and we want to specify in which apartment number or when, if there's apartment number associated with a person, we want to print that out. So what we need to do in that case, so first we need to check whether the person, the residence property of the person is set to something. So here in the first line, if let the residence equals person.residence, we'll try to assign the residence. Oh, that will get tricky. We'll assign residence to the residence constant that we are assigning here. So we only get into the second line if the person has a residence object where there is something in there. So the residence was not set to nil. So then in the second line, we again check whether the residence also has an address set, or if the address is nil. So here the address is set to the residence.address. And if that's possible, if address is set to something and it's not nil, then we will continue. And in the third line, then we check for the apartment number. So at this here in the third line, we are already sure that the person has a residence object set, has an address object set, and now we're trying to see whether also there's an apartment number set. So again, we try to assign the apartment number to the address.apartment number and have that in the if let clause. And then at this point, we know that everything existed and was set. So then I can print out he or she lives in apartment number and print out the apartment. And this is not an optional. This is a string. Why is it string for a number? Bad example in this case, or bad typesetting, but it still works. So this is then a string. It's not an optional. At this point, it won't be nil. But yeah, that is something that is quite convoluted and a lot to read, to go through. So there's also a shorter version how you can do that. And that is what is called optional chaining. So what you're trying here is essentially all these questions or all these assignments you did here individually, you try to do at once. So you have if let the apartment number, you directly try to access the apartment number by accessing the residence with a question mark behind it. A residence might have an address, that's also optional. So again, the question mark, and then access the apartment number. And if any of these elements are nil, then this will not be true. So we will not get here to the next line. But if there's a residence, if there's an address associated, and if there's an apartment number, then this will be assigned to the apartment number, and I can print it out. Makes it easier to read, and you will see that often for frameworks as well, where you then drill deeper into the properties, and then if everything is set, everything works out, then you directly assign it and can use it. So this is something you will also see quite often. Are there any questions more about optionals and how to handle them at this stage? Okay. If not, we'll move over to the next topic in Swift we'll talk about, which is typecasting and inspection. So this is also helpful for optionals, but in general, you will also often want to assign different types or want to make sure, check in code whether there's something specific, a specific type in a variable. So again, let's look at an example. Here we have, I already saw the question why it's not a struct. Yes, it's often a personal decision. Usually they say, okay, start with a struct, and then if you need inheritance, then you can use classes. So here, since we have inheritance, we're using classes. And the previous example, I think struct would have also worked. But yeah. So here, to start, we have class vehicle that holds can have a lot of or can take properties of different vehicles. And we're subclassing that with the class car. Car is a vehicle, yes. And there's also class motorcycle, which is also a vehicle. And then somewhere in our code, we have a function that returns an array of vehicles. So that function might be used to list up all the vehicles in a car park or company which you can rent or whatever. So that will be a function that gives me back an array of vehicles. Could be cars in there, can be motorcycles in there. It will always be a vehicle. So now if I want to work with that, if I want to go through that array, and if it's a car, I want to do one thing. If it's a motorcycle, I want to do another thing. I need to be able to check what type is that vehicle that I'm currently using. And for that, you can use as with a question mark. So for example, here, if we iterate over the vehicles array, we have then for vehicle in vehicles. So that means within that loop, I always have vehicle or in a variable of type vehicle that I can work with. So now I'm trying to, checking if that vehicle that I'm currently having is, for example, a car. And how I do that is I'm trying to assign a new constant car, and I assign that vehicle, and then as with a question mark, car. So what this does, it's trying to cast the vehicle that I'm currently working with as a car object. And if that works, then I'm assigning that to my new constant, and this will be true, and I can inside these brackets work with the car constant, and I will be sure that that this is a car. So I can call all the different car functions that I've defined on that. And then similarly, I can also try to cast it as a motorcycle. So that motorcycle equals vehicle as with a question mark motorcycle is again trying to take the vehicle, casting it as a motorcycle, and assigning it to my new constant. And I can then inside the brackets be sure motorcycle is also of type motorcycle. So it's similar to the unwrapping or assigning of an optional, where I'm trying something and it might work, it might not work. If it works, I'm assigning that and continue with that, and I can be sure that the type is correct and set. And otherwise, I will need to handle it differently. And similar to the forced unwrapping of optionals, there's also a forced casting that I can use. And again, it's with the exclamation point, where I here try, okay, I get all vehicles from Porsche, and I know all of them will be a car, and I'm trying then with as exclamation point in a car array, trying to assign that this new type to that. But again, it's something you need to be sure that this is the case, and this will work. Because if it's not working, if it's not possible to cast this variable to a different type, then your app will also crash at runtime. So all of these things are again making it sure that the compiler can be as sure as possible that everything will work and you've checked everything, but you can override that to make it a little bit simpler if you're really sure that something is in there, and assign it then. But then, if it's not true, if you missed something, then it might crash at runtime. And it's also something with the exclamation point you can also do for variables, where you can, if you specify the type, that you can make sure, it isn't optional, but I'm sure that it is in there, and I will use it without being optional. But the best style is, check the types and then assign it accordingly. But if we look at types, there's also the any type, or also any object. And that is something you can have. That just means could be anything. There, the compiler will not check what you put in there. So, for example, here we create an array of type any, and assign it. First item there is an integer, then we have a string, then we have a double, then we have an object in there. Since functions are also their own type, I could also have a function that I assign in there. But then if I really want to use it, for example, the first item here, if I want to use it also as an integer, I need to cast it again. So here then, if let the first item I try to cast as an integer, then I would be able to also add another integer to it, and that would work. But I it wouldn't be possible to just take the first item and then add 4 to it, because yeah, you can't add something to the anytime. But in some case, it might help to do that. And any object is then something that only applies to objects, where you can have represent any class with it, but in this case, and not a struct. For that, you can use any. Any questions that came up about this casting or any type at this point? If so, then just interrupt me. Otherwise, we'll continue with the guard statement. And guard is something that helps you to also make more readable code. It's very closely related to if statements, but you can use it to simplify everything that you're using there. So let's consider this example. We have want to check what we need to sing for a birthday. So if we have our function sing happy birthday. For that, we first need to check, well, does anyone have a birthday today? So if birthday is today is true, then we can continue. If there are invited guests, if our number of invited guests is bigger, then we continue and check then whether the candles are lit. And if that all is set, then we can sing happy birthday. But then we need to make sure about the other cases. If not all the candles are lit, then we need to specify or print out candles haven't been lit. We need to do that first because we can, before we can sing happy birthday. If there are no invited guests, then it's just a family party. How do we handle that? And then if no one has birthday today, then we print out, okay, nothing to sing, no one to sing happy birthday for. There's no birthday. That works. That is totally fine code, but it's not really easy to read. Problem is that always the else case is very far away from the true case. So it's difficult to match what all belongs together. And for that, the guard command can help. So with guard, we check, similar to the if statement, check a condition, but then we first handle the else case, where we then specify what should happen if that is false, and we return from that point. So we need to leave the scope at that sense. And then after the guard command, then we know, okay, that condition was correct, and we can continue from there. So if you write the sing happy birthday example there from the left with the guard statement, we have this setup. So first then we check, does anyone have birthdays today? And if that's not true, then we handle, okay, no one has birthday today, and we return, and we're done with that, that function at this point. If we make it to this line, we are already sure that that is true. So that it is someone's birthday today. And then we check for the invited guests. And if there are no invited guests, so the number isn't bigger than 0, then we print out, it's just a family party, and we return from that point. So we directly handle what should happen if that's not true. And then for the last one, if the candles are lit, if that's not true, then we need to first light the candles or specify they have to be lit and return. And if all that is true, then we are here at the end and we know, okay, candles are lit, guests are there, someone's birthday today, and then we sing happy birthday. So it is really the same as on the left side. It's just a little bit more easy to read because you have all your cases close together, and you don't need to indent everything here. It's really getting hard to read what belongs where, while here you don't really need to have that indentation all the time. So, and that also makes it easier regarding the scope of your parameters. So for example, if we have an if statement, we try to create or assign a constant x with the x goose.x. And then this constant x is only available in the brackets. Afterwards, that scope is gone. You don't really have access to the x anymore. So you need to handle everything in those brackets. But for the guard statement, it is the other way around. So first you have your guard statement where you try to assign something or checking something. And if that's not possible, if you can't assign it or if there's something wrong, then you immediately return. So for that, the compiler then knows that the x constant will be available afterwards. So you don't really need that indentation. You don't need to check it anymore. You know that afterwards that is there and that has worked. And that's, yeah, what makes it also so good to use with optionals, that probably goose.x is an optional, and you're trying to assign it here, or it is an optional and trying to assign it. If that works, then you can use it afterwards. But if it's not, then you have to return. So if you have a lot of optionals to work with, having their if-let statements will be quite a big of indentations that you need if you do that a lot of times, one after the other. And here it's much more easier to read. And it's also possible, similar to the if-let statement, to do the unwrapping multiple times in one call. So here we have a function process book that gets an optional title, gets an optional double for the price, or and an optional int for pages. We can have a guard statement that tries first to unpack the title. So assign title to the title, price to the price, and pages to the pages. And if any of that doesn't work, if any of those were nil, then we directly return. So afterwards, we can be sure there is a title, there is a price, and there is a number of pages that I have, and I can print that out directly in Access and work with that directly. So yeah, there is no enforced rule that you should use guard in these cases or if-let in those cases. It's a type of personal preference, but in my opinion, guard really helps to quickly check things that need to be set, that need to be true, and then return if that's not the case, or handle that if that's not the case, and then you're aware that everything is set. All right, so from that on, we'll move over to enumerations. And enumerations are another concept that is very often used and very helpful in Swift. And what an enumeration is, or where it's often most used, where you have a different set of cases that some enumeration can take. So example that we have here is the compass point can point north, point east, south, or west. And we only want to have these different directions. So to create this enumeration, we have the keyword enum, then the name of our enumeration. And this is also written in uppercase. And then we have the different cases that the enum can take. But we can also write it in one line where it's separated by commas. So north, comma, east, comma, south, comma, west. And what this does, it allows very quick access to a different set of values that something could take or should take. So for example, if we using the enumeration for a compass, can assign it to a new variable where we have compass heading, and then assign it to compass point.west. This will set compass heading as a compass point type. So now for compass heading, we can only assign different directions that are also possible with compass point. So, and this is why this is helpful, is make sure that you use the correct terms, that you use the correct values for a type. So if we assign the type compass point to here another heading, we can assign it directly with an equal, and then we don't need to even to specify that it's a compass point, because we assigned that with the type directly. You can simply write .west, and we'll assign the compass point .west to this another heading. Or if we change it to .north, it will also assign this. In one way where this is quite helpful is, again, for deciding what to do if you have a compass point variable. So, for example, you can easily use switch statements. If we have our compass heading now set to west, we can directly switch over that compass heading and check the different cases. So we check for the case .north, can write I'm heading north. Same for .east, for .south or .west. I can immediately check that because these are the cases or the different cases that the compass point can take. And in this case, since you having a switch statement over an enum, you can also be sure whether you've checked all the different cases. So since we have here for all the different cases that the compass point can take a case, we don't even need a default statement because it can't be something else. It can only be north, east, south, or west. So that is one instance where then a default statement isn't needed for a switch statement, for example. But again, there are also then advantages, again, for type safety. So think of this example where we have a movie, we have our struct movie. A movie has a name, a release year, and a genre. And while for name or release year, numbers are quite, number string is suitable, genre string can work. Here in the example where we have the movie Finding Dory from 2016, and we signed it the genre animated. Well, probably it should be animated, but you have a typo in there. So that would work. But if you then later on check all your movie database and check for animated movies, this won't come up because it's written wrong. Or we can just simply write something nonsensical and give it another string value. You have genre Tom, which doesn't make any sense. But here again, if we used enumerations, that can really help us to make sure that there is a sensible genre. So if we have, for example, our enum genre, and we create it with the different cases, animated, action, romance, documentary, biography, thriller, those are the cases that the genre can be. So for our movie struct, then instead of the type string, we specify that genre is of type genre. Then can only be one of these cases that we defined before. And then again, we also need to specify the genre is .animated because we already know it is of type genre, and then the specific case animated. And that makes it more type safe because you know if we iterate then overall movies and check for the genres, what different cases can there be, and can list it all more easily. Any questions about enumerations at this point? Doesn't seem to be. If there's something coming up, then also let me know, or after the lecture, write me a mail or something. Okay, so that's for the Swift portion of this week's lecture. And we'll now continue with Xcode and looking there at Segways, navigation controller, and tab bar controller. And the reason why we look at that, so far we only have one screen that we only looked at. But if we want to have multiple screens, how do we navigate between those? And segues are the name of transitions between different screens. I've already set up a new project in Xcode. and simply just for the navigation demo. So everything is, if you just start a normal app project in Xcode, it will look like this. So far, we only have one screen that we used so far. And we already saw that if I want to, for example, add a button to that, I'm simply just dragging that in here, and yeah, I can use that button. I can connect it with my code with an action and react to that accordingly. But now if we want to have a second screen, it's quite similar. So first, I'm just looking here for a view controller, and I'm dragging that into my storyboard. And that will, yeah, create another screen in my project. So, and to be able to differentiate them a little bit more easily, let's make that one red. It's the very in-your-face colors, but should make it then simpler to see. And now if I just want to transition from my original view controller to the next one, I'm just right-click and dragging then to the new screen, or holding down the option key and dragging. And if I release there, then I get a set of segues that I can perform. And the easiest or the simplest you will use most often is probably the show segue, because the show segue interprets the context where you're using the segue at the moment, and then determine the transition accordingly. So, for example, if I now select the show segue, we'll see for one here this connection that was set up between those view controllers, and our view controller already then shifted the appearance. So I have just this layer here on top. And what happened here is that that interface builder determined, okay, this is a transition from one screen to the other. There's no particular context around it. I will use the modally presenting segue, and that is, this one is shifting in from the bottom and overlaying over the other view controller. So if I just compile this and let it run on the simulator, we will directly see that. And so the show segue will automatically determine that. Let's see that the compiler, that the simulator is running. That will take some time. True. So here our app is then starting. Does it start? Does it not start? Yeah, there we go. So here we have our initial red view controller, and if I click on the button, then our yellow view controller is drawing, and I can dismiss it by pulling back down, and that way I'm returning to the original one. And we can also continue that. So if I create another view controller, have that here beside, giving that green color, adding a button to our yellow view controller so that I can transition from here, again with show, and that will directly overlay it that way. In this case, then I can add new layers to our app. So from our initial view controller, switching over to the yellow one, click that, and you can see also there's the original view controller here in the background, and I can navigate back one by one. But the problem is, okay, how do I now get back from the green controller maybe directly to the yellow controller? One easy option or easy idea would be I'm creating then another segue this way. problem with that is we then have a loop. So clicking on the red view controller, going over to the yellow one, going over to the green one, and if I then go to the red one, we'll add another one on top. It will always be that level. So if it's not going back to the original one, but I'm instead using another one that I have on top there. So that does work. For that use case, there's something called unwinding segues. And unwinding segues are a little bit different from those that I connect up here in the interface builder directly, because it's something that I specify in code for the view controller where I'm navigating to. So there is a construct where I just add a function that takes a storyboard segue as the parameter. And that will help the interface builder determine what to do. So what I will add here first, since it's something about the interface builder, use an IB action, then a function unwind to red, and I'm just using calling it unwind segue, and is of type UI storyboard segue. And yeah, don't add anything to that function. So what that function does first with the IB action keyword, telling interface builder that this is something that interface builder can work with, and a function that has just one parameter of type UI storyboard segue tells me, okay, this is something I can navigate to, or tells the interface builder that I can navigate to. And this is something that is connected here with the exit portion of our view controller. So instead of using or connecting from that button to some other view controller directly, I'm dragging from my button to this exit point. If I release there, I already get the unwind to red function that I just created in our view controller. And if I hook that up, this is now then an unwind segue that goes from this view controller I'm at the moment to the view controller that I specified. And within the code of my function, I could handle, for example, something like passing over data, grabbing something that it was on the original view controller and setting everything up, and that would work. So if we now build this one, then we can again just navigate to our green view controller. And if I now press the button, you can see, okay, everything went back down and I'm back at my original view controller that I navigated from. Okay, by the way, the command or the errors or output that is here in the console, that is probably, again, something that Xcode is done internally that is not working as intended, so it's writing out, but yeah, nothing I can do at this point. Yeah, Andreas.
I got a question. Do all the view controllers, the red, the yellow, and the green one, share the same code base? Because I find it confusing that like view controller has a double meaning.
Yeah, it is a little bit confusing. And no, they're not at this point. The view controller that I've added manually, that I dragged out, we, for example, can go here for the what do they call that? Identity inspector. Here we see the class is not set to anything custom. It's just a regular UI view controller. So it's a base element that I included. But if you create a project, the original or initial view controller is already set up. So there I have here the class set to view controller, which is the one that I've defined here. So this is, that view controller has the view controller code base. These are just really off the line view controllers. I can't do anything in code with those. They're just in interface builder now for setting up. I can navigate to them, but there's nothing I don't have a view controller file here. I would
Okay.
need to assign that to a specific one.
Okay. Okay. Thank you.
Okay. All right. So that about is about simple segues, but you've often, or when we spoke about productivity applications, you saw already saw navigation controllers, which are a way to really drill down and navigate to more specific view controllers that we want to interact with. And navigation controllers also something that they behave like a stack. So you put another thing really on top of the other one. And if I go back to the one underneath. And navigation controller is something that is then handling the stack. So if I want to use a navigation controller in my project, I have two ways. For one option is this little button down here is the embedding menu. Oh, probably you can't see that at the moment. What you see there is also, let me quickly just increase this size here. That's probably simpler. Okay, so what I have here can embed it in navigation controller or in a tab bar controller. This is also in the menu of Xcode. If I just go to editor, I can also embed in and then select navigation controller. And if I do that, let me quickly make this smaller again so that I don't get confused. Doesn't want stays that way. So what it automatically changes here is I have now a navigation controller in front of my project. And this arrow here is always defining the entry point of my whole app. So I'm starting in the navigation controller. And what also happened is that the presentation of the yellow and the green view controller already shifted. So it's not something, not anymore something that laid on top of the red view controller or the yellow view controller, but instead I already have a back button here, and it's the full screen visualization. And that is because in this case now the show segue that we define sees that, okay, the context of our red view controller is inside of a navigation controller, so it employs directly that transition that it looks like the normal navigation controller. So, and I have here then also the navigation bar, and that is also now in all of these different view controllers that come afterwards, they also have a navigation bar. Can also see that directly within our outline here, there's a navigation item that was assigned to our view controller. And in the settings of this navigation item, I have a couple of elements that I can set up. So for example, I can give it a title that I know our red view controller has the title red. Or for the back button, you can see here that, let me go a little bit closer, that the back button on the yellow view controller directly adapted the title of the previous one. So that is all something you get for free or automatically if you use the navigation controller. But I can also specify what I want this to say. I can also say go to red. This will address the visualization of the back button here. And yeah, other settings, I can of course also do this here for the yellow screen. And here on the green one. But yeah, other appearances or other changes that I can make. I can also specify here if I select the navigation bar from my navigation controller. You can see here there's a lot of different things that I can set up, from the color of the bar that is then shown there on top, whether it's transparent, what title or what font should be in the title. That is all something you define for your navigation controller. And it will then carry over to the other view controllers that follow this. But I can also put more items in here. So if I again press this plus, so the plus here stands for the library. As already saw, question for how do I get to the view controller, that would also be with this plus, and I then can search for the different objects that I put in here. So that view controller would show up, but can also have a bar button item, which is something that I can add to this navigation bar. So for example, if I add this here in the navigation bar of our green view controller, I then have a bar button item that I can interact with. And there are some that are directly defined from the system, how they look like. So for example, an add is a plus button, redo, well, just says redo, interesting. Search, probably a magnifying glass. But I can, yeah, also have my own elements in there. So for example, if I want to use this one as the way to return to my red view controller, I can give that the name. And similar to the button in the center of the screen, I connect this button and connect it to the unwind Segway that we created. And I have it then here that I can press this button to return to the original view controller. Something else that's maybe also interesting to know, the appearance of the navigation bar. For example, in the settings of iOS, you also often see that there are quite large titles. So here it prefers large titles. If I click that, it will automatically shift that over to this appearance that is a large title, and the item to go back is then on top of that. And it is something here you for the navigation controller, you just specify that it prefers large items, large titles, but I can individually also specify how it should look like. So in the navigation item, I can specify whether the large item, how that should behave. So normally it's set to automatic. In that case, it will look like what is the context where this view controller shows up. If that is a large title, I will also show a large title. If it's, of course, I set it to always, or I set it to never, then it will also be a smaller title. And you can see the automatic title here in the green view controller directly shifted over also to a small title, because the context now is also a small title. But an automatic, yeah, it will take over what you have. So now if we build that one, then we'll have here our red view controller. And if I press that button, now we have the visualization, the animation that it pushes over from the side and it's covering everything. And if I go back, that navigation is all there included. If I go to the yellow one, the green one, I have here my item pop, and that is now also using the animation that fits this context. And the reason why I also had originally directly a button that allowed me to go back, even though I also have the gestures, is that it's also a convention that it's possible to interact with the interface just with buttons, that I have a button to go back because it's visual. I see what I can do, where I need to tap to go back. It's something that Apple is also not conforming to in many locations. There are a lot of gestures, but if you don't know about them, you don't know how to interact with those. So it's always a good idea to also have an explicit button to trigger an action. Okay, so that for simple transitioning between screens and using a navigation controller. But what if I want to now pass over information, if I want to react to something that the user maybe has entered on one screen and I want to show it on the next one? So for that, let me add a text field to our red view controller. And what I want to do is just once I click the transition button to the yellow view controller, I want to change the title to whatever I put into this text field. So how I do that? First, I need a way to access this the text that is inside of the text field. So for that, I'm using the assistant view and creating an outlet for our text field. Let's call it text field. And that way I can then check in code what is input in that text field, and I can react to that. So, but now the question is, how do I know when the user has pressed the button? So far, we've only linked here everything in interface builder. I don't have a function where I can check what is in the code there. And the way I can do that is every view controller, everything that inherits from UI view controller, also has a function that is called before such a segue occurs. And that's called the prepare for segue method. So if I just type in prepare, I see here directly the method prepare for segue with a specific sender. So if I select that, this function is called directly before the segue. So within the segue, I have also an argument segue, and let's just look. Segway has a couple of different or interesting properties that I can look at. So one is the destination. Destination is of type UI view controller. So I can see where would this transition take me. What is at the end of the transition? I have an identifier that I can set for the segue, so I can differentiate between different segues within the function to check which one is calling at the moment. And I have the source, which is most likely the view controller that I started with. Source will not use that often, but the destination is something that is quite interesting. Normally, you would probably have a specific view controller that is at the end of the segue. So I would need here to check what is the type of that view controller and cast it then appropriately. If we just want to set the title, which is something that every view controller has, I don't need that casting. So instead, what I just do, I'm taking the destination. Now I have that view controller, the destination view controller, and to change the item, accessing that view controller's navigation item, and then the title in there. And I set that to the text field, text. So in that line, I'm checking where does this segue lead to, and from that destination, I'm taking the navigation item and the title in there and assign our text to that. So, and only with that line of code, if we start our app again, I now have here our text, my text field, and if I just type hello in there and I transition, now the title hello is changed on the following view controller. So that is something where I can pass information over to a new view controller that is called, which is very often helpful if you have a selection on one view controller and the next one should be already set up with, for example, the contact information or something. So, but the other way around is something, if I want to call a segue or transition based on something that I have in my code. So for that, let me quickly just reset everything and remove all the transitions that we have. So now I want to have a switch here on my red view controller and only want to transition if that switch is active. So if I look for a switch, I will get the UI switch. Place this here, and then I want to have two buttons, one for going to the yellow view controller and one for going to the red view controller. And let's call this one yellow and this one green. So if I tap the yellow button and the switch is active, then I want to transition to the yellow view controller. If I tap the green button and the switch is active, I want to go to the green view controller. Now to set up those segues that I have the possibility for that navigation, I drag from my view controller first to the yellow one, set up one connection, and set up to the other. I could, of course, also draw from the buttons, then it's linked to those. For this example, I am just connecting or creating segues from the view controller to another one. And I already mentioned that a segue also has an identifier. Can specify that here in interface builder. So that one should be to the yellow view controller and green to the green view controller. So now our view controller has two segues, one going to yellow, one going to green. I can only differentiate between them. Why is that not embedded anymore in the view control navigation controller? Interesting. Then let's embed it again. So, all right. So, but if I want to check whether the switch is set, what I need for those, I need to again have an outlet for my switch. So what do we call this? A Segway switch that I can access. And then to make it interesting, I have just a button pressed function or action for our green and our yellow button. And automatically, the type is usually only set to any, but I can also set that the type is of UI button. So if I connect this one, you can see that the sender is directly set to UI button, because I know I have set it from the connected from the button, and that I will get that information. And the yellow one, I'm just simply connecting also to that action by dragging it over. That this is highlighted, and I connect those. So now I've set all the connections up. I can access the switch, and I can access, or I will get notified if the user presses one of these buttons. So what do we do within our function here? So first, I want to see whether the switch is set. So first, how I can do that, if I have my Segway switch, has a property is on, which is a Boolean. So if that is on, this will be true. I also want to know which button was pressed. And one way how I could do that in this case is I gave the buttons different titles. So one is yellow, one is green. So I could get button title. And with that, I can look here at the title label of that button. There I just get the label, and that label has a text. So the label is an optional, so that is why the question mark is here appearing. And let me just also let's just use state. So now I know the state, whether the Segway switch is switched on, and I know the title of the button. So with that title, I can define which Segway I want to call. So if the state is true, if the switch is set on, and I can assign, let's just do that here. I can unwrap this optional that I have a button title, or I have the title of the button if that is set. If that is all the case, then I know, okay, I should transition to a new state, and I have the title. So it's now only a question which one, which Segway do I call and how. So to call a Segway from code, it's a perform Segway with identifier is the name of the call of the method. So with identifier takes a string. Now it's not the best clean code that I'm writing here. It's just to show you the capabilities. I gave the Segways the same identifier than the title of the buttons. So here I'm just using the button title as my identifier. Sender I don't care about, so it's nil. And if I just call that or compile that and run that, the perform Segway is then looking for Segway with the identifier and is performing that, carrying that out. And the identifier for the yellow one was also yellow, so that Segway is called if I click on yellow, and the green Segway is called if I click on green. If I now disable the switch here, I can click on yellow, but nothing will happen. So that is something where I perform a Segway from code directly depending on the state of the variables in my UI. Would also be an easier way to check whether a Segway should be carried out, and that is also appropriately named should perform Segway. There I have a method that returns a Boolean. Yes, if it returns true, then it will perform the Segway that would have happened, and no, I can carry it or it can block that Segway from actually triggering. So I could check in that method whether the state is true or false, and then link back on that. Yes, Andreas.
I got a question. Can you address specific view controllers in the code in this code view controller? Could you, for example, say red dot something, or is that not possible?
I mean, the red view controller is this view controller. So
okay,
if
sure.
Self dot would be myself. If I want to access a different one, I need some reference to that. I need to have it passed over. So that is, for example, if I have my Segway, the destination, there I get where this destination ends up, and I would need to cast it to a specific one. If I have maybe written a green view controller, then I would need to cast this destination to a green view controller and access it. I don't have a global access directly to anything that exists.
Okay, so you sort of work with elements which you can identify here. For example, the Segway switch.
Yes, because that is connected in my storyboard. I have this outlet set up. Let me quickly just show the assistant again. This assistant is here, shows me the view controller that is associated with this, this view controller here. So that is the explicit connection I make from the element in my UI to my code. And same for the buttons with the actions that I can trigger. But if I, the Segways that are connected here, they're not directly visible here in code, but they are connected in our interface builder. So in interface builder, from our red view controller, there is a Segway with the identifier yellow. That is the connection it has. And the yellow Segway, that knows where does it originate from, where does it lead to. So in code, I can, if I get that Segway, I can then check, okay, which one is it? Where do I need to go? How do I work from there?
All right. And can you access, like if I create a button in the green view controller, I can also set up a connection for the code view controller, right? That is.
Yes, at the moment, it won't work because there is no specific view controller set for this.
Okay.
Because if I want, as I showed here, the class is there is no specific custom view controller. So there is no specific custom code that I can write my code into. In order to do that, I'm a little bit over time, but let me quickly, if I create a new file, let's just, I could just, let's quickly try that out. Green view controller. It's now breaking all the conventions. No, that was wrong. That didn't work. That's the wrong one. If I create a green view controller where I can directly specify, it's probably Cocoa Touch class. That was where I didn't select the right one. Where I directly have the link to a view controller, it would be possible in this view controller to specify that it is now a green view controller, and then I would be able to make that connection.
All right, got it. Okay, thank you.
All right, yeah, so that it is it for today. Tomorrow I will start then with another type of navigation aid that Interface Builder gives you, which is a tab bar controller. But for today, this is it. So thanks a lot for being there, and yeah, see you tomorrow.
This content was provided by RWTH Aachen University.